First, we have Jeff Milton. If you don't know Jeff, then this might be your first meeting. Jeff serves as the Bridge Preservation Specialist for the Structure and Bridge Division of VDOT, where he served for 44 years. And Jeff will be discussing VDOT's laser coating removal research.
I'm going to talk about VDOT's laser coating research. VDOT is conducting research investigating the use of high wattage lasers for laser ablation coating removal systems for removing coatings from existing bridges. These lasers have become available now at costs that are a lot more reasonable than they used to be. And so the objective of this project is to determine the feasibility of using the high wattage lasers to remove coatings from our bridges. It's a little bit of the theory about how the laser coating removal works. It's an ablative process that can be applied to a variety of substrates, including metal. Laser energy is focused onto the surface and is absorbed into the coating, resulting in decomposition and removal of the coating and causing only minimal increase in substrate temperature. The key advantages in the use of lasers for coating removal include their non-contact nature and the fact that they use no secondary medium that contributes to waste streams, aka there is no blasting media that has to be disposed of. Basically, the surface layer absorbs the laser energy and is converted into a vapor. So the bottom line is the laser basically vaporizes the coating and sucks it up into a filter, and the only thing you have to dispose of is the filters themselves from the laser unit. So there's really, other than the filters in the laser unit, there's really no hazardous waste disposal to be concerned with. Everybody's seen this picture somewhere along the line. Coatings on steel beams tend to fail at the ends of the beams under leaking expansion joints. I'm sure you've all got a picture like this somewhere. And so, of course, the current practice requires containment structures for removing of existing coatings. Although coating failures may generally be limited to about 15% of the total beam lengths, the economics of constructing containment structures and many times may lead to the decision to recoat the entire surface. If you've got a 3-span grade separation structure, for example, and you have to build a containment system around the ends of all the beams, it may very well be just as economical to contain the entire structure and recoat it. SSPC has some kind of general rules of thumb that if you remove more than 16% of the surface area of the coating, you are just as economical to go ahead and completely remove all of the coating and do a recoat. If alternative technologies were available to allow contractors to remove coatings at only the beam ends and to do so without containment, we think we could address a whole lot more of our bridge coating needs. This research project has got 5 phases, and I'll go through them kind of quickly. Phase 1 was conducted in October of 2016 at a vendor location. We basically took some beams from an existing in-service bridge that was going to be demolished, took those samples to the vendor location, and we also, as part of this phase 1 testing, we retained an industrial hygiene group to monitor the operation. What they found was very encouraging. The air monitoring results indicated that personal and area concentrations were below the OSHA permissible exposure limit, that all area and personal samples were below laboratory detection limits, and that the TCLP analysis for 8 metals was performed, and of the 3 filters, the particle filter was hazardous for lead. So again, really, from a worker protection point of view, we have determined, and I'll go into this in a little more detail, we have determined that individuals can use this laser to remove lead coatings and not require any of the OSHA personal protective equipment or anything like that. And again, so the only real environmental and health and protection issue is the disposal of the filters from the laser equipment. This is some photos of the inside work we did in phase 1. Top left is just a photograph of the laser equipment. It's an ADAPT laser, 1,000 watt laser. And then you can see in the other photos the handheld equipment that is attached to the main unit. There's some more photos showing the removal of the material. And you can see these beams are in pretty bad shape. We had a lot of rust on them and a lot of, well, basically most of the paint was gone. It was just rust. Another photo, how it removed the layer. And this is kind of an interesting slide here. This is a picture of a flange after the laser removal process has been used. You can see it's a pretty bright, shiny finish that we have there. It doesn't leave a profile, which may be, in some people's eyes, a problem, but we have discovered a paint system we can use that doesn't require a profile. It's an epoxy mastic paint, so we could use the laser without a profile and use this epoxy mastic paint as the new coating. Phase two, we were real pleased with the way things worked in phase one, so we decided to take this equipment on the road. August of 2017, we actually transported the laser equipment to a site in Prince Edward County, Virginia. Tried to perform some work on some beam ends and diaphragms. Biggest issue we had was hard to reach places such as some of the beam ends and the bulkheads and bearings with unusual geometries, but again, all of the industrial hygiene readings were no problem. Here's a couple of photos of showing what we did in the field, and you can see it's doing a great job. Again, the two potential drawbacks are going around bearings and some of the sharp corners because of the size of the laser head, and then the slow production rate. Phase three, we decided to take some bearings again to the same private facility and to see if we could improve our production on the bearings in some of the areas that were hard to get to. So we used a 500-watt laser as opposed to a 1,000-watt laser, which had a smaller head. To doing that, we determined that the 500-watt laser was really the only viable option for cleaning around bearings and in these tight spaces. That's just some photos of the bearings that we cleaned in phase three. Phase four, which was probably one of the most telling, we again went back to the same private facility in July and August of last year, and we transported some more beams from an old VDOT bridge to this facility. And the purpose of this was to conduct another industrial hygiene study as a means of determining whether the laser ablation system can be used as a feasible engineering control, whether the laser ablation system successfully reduced the risk of employee exposure. And one of the reasons we were doing this is our state forces do a lot of work of demolishing small existing bridges. And when in doing that, they have to do a lot of what we call hot work, cutting and grinding and that kind of thing. And if you've still got your lead-based paint on the beams when you're doing that, then you basically have to have all of your employees that are involved in that in the OSHA lead program and everything that entails. So on July the 30th, we had some employees from this private organization use the laser ablation system to completely remove about 55 inches of coating on two beams that we had transported to the site. And then on August 1st, we completed some task-based work, what we call hot work, on each one of the beams as a means of evaluating whether the laser ablation system effectively removed enough lead coating to reduce worker hazards. And we did torch cutting, we did plasma cutting, we did grinding on these beams after we had removed the coating with the laser. And what we found was that the laser ablation process can successfully reduce the risk of employee exposure during VDOT beam de-leading and during hot work conducted on the de-leaded beams where the coating was completely removed. So if we can use this laser to completely remove the coating on an existing beam or steel surface, then there are a couple of good things to that. First of all, the people using the laser do not have to have any industrial hygiene protections, and they're not subject to the OSHA lead and construction requirements. And then if you go back to those steel members subsequently, and you need to do some cutting or grinding or welding, then that's no problem either from an industrial hygiene or environmental perspective. Phase five was performed at the FHWA Turner Fairbanks Lab in Northern Virginia. And the idea of this was to perform some testing on the samples that were cleaned during the phase one. So the following tests were performed to evaluate the steel surface prepared for corrosion and coating performance compared to a grit blasted surface. So we're trying to compare the laser clean surface to abrasive blasted surface. We looked at surface profile, tensile strength, adhesion testing, adhesion of the coating, soluble salts, electrochemical testing, and coating performance after cyclic exposure. Coatings were applied to these beams and tests were performed, And the following tests were performed after the samples were coated with a coating that was provided by VDOT. Basically, it was an epoxy mastic coating, which doesn't typically require a surface profile. So we looked at the dry film thickness, gloss loss, color change, adhesion, and rust creepage. So what did we find out in all of these phases and all of this testing? We found out that the laser effectively removes the coatings investigated, including lead alkyd paints. The laser does not detrimentally affect the mechanical properties or the chemical composition of the steel. The coating adhesion was determined to be satisfactory with an adhesion testing revealing average pull-off pressures of 1,800 psi when using this epoxy mastic coating. And the industrial hygiene study results showed that the engineering controls associated with the laser were effective in maintaining potential exposures for the laser operator below the current exposure limits. So the laser can be employed as a lead removal technique in preparation for other processes, like I mentioned. If you've got, the laser will not remove coatings sandwiched between two steel beams. If you've got like an old beam that was composed of angles, back-to-back angles, problematic whether the laser will remove the coatings there. Tight spaces such as bearings remain a challenge, and the production rate remains a challenge. But again, the laser process can successfully reduce the risk of employee exposure during beam deleading and hot work. So the recommendations from this research project will provide VDOT with a safer and more environmentally friendly option for coating removal from steel bridge elements. Besides material, labor, and equipment costs, the traditional painting operation must also include the often increasing cost of containment, traffic control, waste disposal, and so forth. So the use of the laser could reduce these costs while ensuring VDOT continues to be good stewards of the environment and maintains the safe working conditions. So what's next? We've been working on this project for about 3 years now. We keep thinking of things that we want to examine in more detail. So the first next step is to publish a formal report for this work, and that report has been drafted, and the draft is in the process of being reviewed. We're going to conduct 2 new research projects that are spin-offs of this. One will be to provide a chance to compare different coating removal methods and recoating options on beams in one of our districts. And then the other is a novel coating removal technologies. This project will focus on improving the production rate of the laser and start investigating the use of induction methods for coating removal. Another thing that we want to look at is possible mechanical assist for the laser equipment. If you notice from the photos, the laser equipment that you have to hold is fairly bulky and can cause some operator fatigue. In addition to the laser ablation, we want to look at the induction method as a possible assist to doing this work. So this is a pretty cool project. I think my wife even thinks it's cool. So this has been very interesting, and I hope you found it interesting. I've got a video I'd like to show you from our phase 2, where we actually went out and did some work on an in-service bridge. Anyway, so like I said, this was the laser was transported to the site in a trailer, and that was the laser thing, and this was the bridge that we were going to work on. And this is the actual video of a guy in the field removing some coating. So anyway, the laser was transported to the site in that trailer you saw in the beginning, and then this is just some video of a worker actually doing some laser coating removal. Now, this is the 1,000 watt larger one, yeah. So we still got a ways to go, but I actually received an email, I think last night, from one of our scientists that has been working on this project, and apparently another company is going to be doing some laser coating removal work at the U.S. Capitol, and I think we may have a chance to go see how that's doing. That's just a shot showing some of the beams after and you can see the red lead, paint there. Couple of days, so like I said, it's pretty slow. And that's one of the things we're working on, is trying to improve the production rate. That's really the biggest drawback right now. But I think it's got potential. And, one of the things that we are probably going to be able to use it for fairly soon is, again, when we've got state forces that are demolishing small steel beam timber deck bridges, and we need to do some, paint removal so they can cut and weld. And this may be a niche, for that. We've been in some contact with the firm in Virginia that owns this equipment, and he is willing to rent us the equipment for the nominal fee of $12,000 a week. But I understand these units cost about $500,000. So, but if you look at the cost of building a containment structure, maybe that's not so bad. So, the research continues, and I think it's just been very interesting. Any questions?
This is pretty cool stuff, Jeff. I know this came out of the scan tour. You weren't the first state to do this, but the fact is that you're working out the details is great. I got a question for you. Actually, I got two questions for you. The first one is, with traditional coatings removal, you got to basically test your substrate afterwards, your remaining metal, for chlorides and sulfates and soluble salts, all that good stuff, right?
Right.
And there's no difference here, right? You still have to do that.
Well, what we found with the testing we did at Turner Fairbanks, that I don't think we'll have to. I think we determined that the laser will actually remove the soluble salts and such things.
Are you going to produce a research project on that? I mean, just the findings so that everybody can see that?
Yes, we're in the process of preparing a report for this whole project now, and the report's been written and it's in the review process. So, but yes, once it's completed, it'll be placed on our website, available for public viewing.
That's great. My other question is this, and you probably can't answer this question all that easily, but you can save on containment. It's a fairly slow process and things of that nature. And I realize that basically you still have to have MOT and other things going over there. Do you have a feel for what type of savings you actually get by using this?
We haven't done a cost analysis, although I think that the final research report will address that, because I've supplied the researchers with some general information about our typical contract costs. I think we may have some of that in our research report when it's issued.
That would be very helpful, because saving money is what everybody's interested in doing.
That's right.
From time to time, states may want to paint the 588 steel, the weathering steel.
Uh-huh.
Do you have any idea if this manner of cleaning would be applicable to?
That's a very good question, and we have not tested that as part of this research. But that's a very good question. I can't really see why you couldn't use it for that. One of the things that we have talked about and we haven't really done in this testing is using this for graffiti removal on concrete surfaces.
Hi, I had my hand up before Jeff. Yes, DOD has done this with airplanes, and it absolutely, at the right strength, does remove soluble salts. It burns them off, basically. And the other comment is, for an airplane, they end up with like a Coke can's worth of ash. So this is the future. Good job. Oh, and again, like you said, the details are an issue. And I'm not sure about the corrosion pits. Most of the surface, for sure, it burns them off, but you want to be sure the profile is addressed. Thank you.
Thank you.
Just a comment on the Core 10 issue, or the E588 issue.
Right.
I've been working with people in Japan, and they've been working with these lasers for a long time. On the Core 10 issue, it burns the salts off.
Okay.
But there's a residual black oxide that remains on the surface, even when they're doing their sandblasting.
Okay.
At least that's what they've been finding. So they get it. They still get that black patina on the surface, but it does remove the chloride.
Okay, that was what I...
When they go over it, so it gets the chloride out of the pits. They have not found any residual salt. So as a chloride removal tool, it's very good.
Yeah, and I think that will depend on what kind of coating. Like I said, we've been using on epoxy mastic, which doesn't really require a profile like a zinc primer does. So anyway, all right, thank you very much.
The preceding was produced by the National Center for Pavement Preservation. More information can be found on the web at pavementpreservation.org. Additional support provided by Michigan State University.